is now starting. All attendees are in listen-only mode.
Okay, so I guess I'll start. Mohammed, did you want to give an introduction or should I just jump in?
No, go ahead, Marcus.
Okay, great, thanks.
Okay. Yep.
Okay, so hello everyone and greetings from Berlin, Germany, and greetings from Ocean Protocol Project. So my name is Marcus Jones and I'm working as a data scientist here at Ocean Protocol. Ocean Protocol is a decentralized blockchain protocol to unlock data for the artificial intelligence ecosystem. So in this webinar, we'll be covering a lot of different topics. So we have, for example, decentralized, and that refers to blockchain technology. Ocean Protocol is running on the Ethereum blockchain ecosystem. And we also have this word artificial intelligence. So there's obviously a lot of topics to cover. The objectives of this webinar, therefore, are to, first of all, give you an overview of what Ocean Protocol is. And because this is a developer-oriented talk, I want to go in more detail about the architecture of Ocean Protocol, and then also how you as a developer can get started to use Ocean Protocol in a, let's say, testnet or a local development environment, and actually start building applications using Ocean Protocol. So I started here at Ocean 1 year ago working as a data scientist, and because it's quite a small company, I'm involved in different levels. I'm involved in basic software engineering, but also understanding how data scientists can use Ocean Protocol to better improve their workflow for data science and artificial intelligence. Okay, so let's get started. First, some motivation. So in the world of data science, this is a very famous paper from 2001, which showed that instead of putting a huge amount of effort and resources and developer time into discovering and building new algorithms, it actually showed that there's an alternate approach, and that is simply to throw more data at an algorithm. So when we talk about algorithms, we're specifically referring to machine learning and artificial intelligence algorithms such as linear regression, logistic regression, and of course, neural networks, deep learning, tree-based algorithms. And these algorithms respond very well to simply having a lot more data. And this is indeed the approach taken by the leading companies of the world. For example, Google, Facebook. These are all companies that are data-driven, and this is the result of this paper is simply that these companies are incentivized to gather incredible amounts of data to improve their value and their business process. For example, Google is actually using AI, probably 10,000 different AI models in production at any given time, and they're all taking advantage of this huge wealth of data to deliver advertising and to deliver better services. So we see that there's this incentive to actually hoard data. So this means to collect the data in one company. And actually for data science and for society as a whole, the idea of Ocean Protocol is to incentivize the unlocking of this data. So this means to make this data more available to data scientists. And there are many new results that are waiting to be discovered if we get the right data to the right people. So we have on the one hand the problem owners and the problem solvers, and then there's this gap. So the problem owners could be like the United Nations Sustainable Development Goal, or some other like healthcare research center. And on the other hand, we have the problem solvers. So the question is, how do we close this gap? So oftentimes the problem owners are also the data owners. And this is the key of Ocean Protocol, is that we want to enable the problem solvers to access this data and to solve these problems on behalf of the problem owners and using storage and compute, for example. So it's not just about the data, it's also about actually training the models on some secure environment. So that's let's say the most basic core thesis of Ocean Protocol is to act as some type of, let's say, public utility network for the artificial intelligence ecosystem. And that's an interesting term because public utility could be something like water or electricity, but actually the blockchain can also be thought of this way. So it's actually owned by everybody. So for example, Bitcoin or Ethereum, it's owned by everybody, or you could also look at it and say it's owned by nobody. It's just a public utility, it just exists. And this allows us to tackle this problem in interesting ways. So again, we're a decentralized data exchange protocol to unlock data. We use blockchain technology to incentivize data sharing in a safe, secure, and transparent manner. And then we want to build this open access platform to build services. And again, this is then the core mission is then Ocean Protocol acting as a public utility for the orchestration of data and artificial intelligence. Okay, so that's sort of the overall picture. And I think it can be best clarified if I jump into some examples. So let's talk about the data science workflow. So on a typical given day for a data scientist, this could be, they would be working on some aspect of this or maybe even the whole picture. The typical workflow would look like taking some data, and that could be driven already by a business problem. And then they would start building up a model pipeline. And that would be, let's say, for data scientists, most common language is Python or maybe some R programming or some other language. And this would then essentially be a script file, which includes some libraries like TensorFlow for deep learning or sklearn for machine learning and pandas. So the typical data science libraries would be included in this pipeline. And so then, of course, the data would be brought to the script, and the script would execute on that data in some type of execution environment. And that could be your local machine, that could be an AWS container, that could be some supercomputer somewhere. The result of this is then the model is trained. And that could be, for example, in a deep learning case, you would have a neural network weights file, and that's coming from, for example, TensorFlow. It might have 0.5 GB of memory space, and you would then take this model and then you would evaluate it. So then you would be looking at the results, like the metrics. So is this an accurate model or not? And you would then typically iterate over this flow many, many times. Once you're happy with this, you would then put it into production. And this means then serving this model behind, for example, a REST API or some other microservice so that it's actually able to make new predictions on unseen data. And finally, you get to the value. Okay, so these are all types of assets. The first type of asset that Ocean Protocol aims to, so the first type of asset that Ocean Protocol registers, and this is the basis of the protocol, is the data itself. So in the Web 2.0 world, we have a universal resource locator, URL. And in the decentralized world, we have a distributed identifier, and that's a DID, and that's a 256-bit string. And this is attached to a data description object, a DID description object. And so this is actually what is actually registered in the protocol. So the DID is registered on chain in the Ethereum blockchain, in our own Ethereum blockchain. And then this is the metadata for this data set. So that what's contained in the DDO is actually the description of this asset. So for data, it could be the type of data. So for example, this is a data set containing 10,000 images, or it's 5,000 insurance records from some time period. It's just describing the asset itself. So we can register this into Ocean Protocol, and I'll make a demonstration of that in a second. We can also register other types of assets, and that's including, for example, the script itself. And that would be, for example, a Python notebook. And in data science, we often use Jupyter notebooks, for example, or IPython notebooks to package our algorithms. Or it could be a pure Python script file. This can also be registered with a DID and a DDO. So again, the DDO would describe that script. And furthermore, the trained weights file itself, so the TensorFlow deep learning file, can also be registered into Ocean Protocol with a DID and a DDO and other assets. So finally, we can also register the entire workflow as a compound asset. And then this would be basically a one-stop shop for this type of problem. And you could publish this and allow other people to purchase this on to marketplace in production now. So this is our marketplace that we have in production, and any of you listening, of course, can try this yourselves. It's commons.oceanprotocol.com, and we can send some links later with the details and links to other types of resources. In general, you would just need to go to oceanprotocol.com so I'll do that now actually, just as a starting point. So just in general, if you want to learn more about the protocol, if you want to check the developer tools, just go to our website at oceanprotocol.com. And there's lots of information there, including blog posts. And yeah, I'll review this at the end of the presentation as well. So back to the Commons Marketplace. So in this Commons Marketplace, we are connected to a blockchain, my blockchain identity, and that is indicated by this icon. So we're connected to a certain blockchain network. So in Ocean Protocol, we have several blockchain networks, including many test networks and one production network, and that's what I'm connected to now. So if you're not familiar with using the Ethereum blockchain in your browser, then you would typically access it using this plugin called MetaMask. So if you've ever used a decentralized application running on the Ethereum mainnet, you would probably be aware of this. And we can connect to different networks. So these are all blockchain networks. So we have the main Ethereum network, which is the main Ethereum network. And then we have a bunch of test networks, but we can also enter our own custom networks. And that's what we've done here. This is our production network that we're connected to. So this is, as a demonstration, we have some Ethereum. So there's actual value in this network possible. And what we have here is a demonstration of a marketplace. And in this case, the marketplace has a number of assets, and we can scroll through them. So we have this concept of channels as well, but we can also search. So let's see if I can find something. So right now it only has a limited number of assets, I think around 1,000. So it's just been seeded with some data assets for demonstration purposes. So here we have a data set for machine learning. I haven't seen this one before, but it's showing the author, the license. So all of this is part of the DDO, actually. This is the description object or the metadata for this data set. And finally, we can actually try to access this file. And this is then going to initiate a series of transactions on the blockchain. So this is actually accessing the smart contracts that we have deployed. And therefore, the value transfer and the ownership is cryptographically secured with this concept. So just like any other Ethereum blockchain project, we're running on smart contracts running in a proof of authority network. So we've now signed for the purchase of this asset. And because this is only a demonstration, the price of the asset is 0. So there's no actual value transfer except for the transaction cost. So that means in Ethereum, whenever you execute a transaction, this has to be processed by the nodes of the network, and they get essentially a mining reward, and that's what this final fee is. So now I've been able to access this asset, and it's then going to start downloading. So we have in this marketplace some channels, and actually we're very excited about sponsoring AI for good, so artificial intelligence to support sustainable development goals, to support other initiatives for good. So we believe a core mission of Ocean Protocol, which is also a nonprofit organization, I should mention, is that we'd like to unlock the data to bring some benefit to society. So the final signature is complete on my purchase, and now we can see that I've actually started to download this data, and now I have access to this data on my local machine. So that was an example of one transaction on this Commons marketplace. So you might be asking, yeah, what's actually the point of this if they're actually assets which are only essentially free in any case? Well, the point is that Ocean Protocol, the Ocean Protocol Foundation as a nonprofit foundation, is not going to be operating such a marketplace for paid assets. This is up to the community. And we would like to see some people listening to this call consider to build such a marketplace. For assets. So for example, if you're working for an e-commerce site, perhaps you have some old data that is not necessary for your business value. And what you could do is you could take this Commons marketplace, which is completely open source, and I'll point to our GitHub repository later, but you could take this marketplace and you could fork our repo, you could then style it to your needs, and instead of registering assets which are free, you would just change the price to whatever you would like. And then you would make this website available, and then you would have a marketplace for e-commerce data that you are personally running. So you'll notice that here, there's no payment provider either. This is all organized by the blockchain. So this MetaMask is enabling value transfer tied to my personal blockchain identity. So you might ask how to publish an asset, and you would go through this publish flow. You would type in the title, so we can just type test asset. You would add files and just go through this, basically adding the metadata to your asset, and that would be basically it. If you wanted to publish multiple assets, we also have a tool which allows you for batch uploading. I think that's about it for that demonstration for the Commons Marketplace. Let me just go back to the slides. Yeah, so one question that we often are asked is also regarding this concept of privacy of data. So you'll notice that as I completed the consume flow, which is purchasing an asset with my blockchain identity, I have this asset local on my disk. And this, for example, is a CSV, but it could also be something that maybe has some value to you, like an SQL database with customer data. So obviously this isn't very useful in terms of paid assets, because actually this asset is now just sitting on my disk, and actually I could even give this to a colleague, or I could sell this, to a friend if I wanted to. So what the key unique selling point of Ocean Protocol, what we really enable is things like being able to train a model without actually seeing the data, or without actually owning the data yourself. And this is done in the following way. So we have some private data, and this is sitting on premise at, for example, a bank, or let's say your private cloud behind a firewall. And on the other side, we would have a data scientist, and again, they would be focused on this value pipeline, and they would build a script using some sample data. So they would never actually get a copy of the private data. They would get the description of the private data or some anonymized sample. And in this way, they would build a pipeline, and they would actually send their algorithm to the owner of the data. So if you were running a private cloud, they would just simply transfer it as a Docker container to you, and you would actually execute this container on their behalf. So this means you are acting as the processor as well. And so from a legal perspective, this avoids a lot of the challenges that we see just even sharing data across even, for example, provincial jurisdictions or municipal governments. Anytime you need to share data, you need to sign a form, you need to involve a lawyer, and this would avoid all of that overhead. So the result would then be the private model, and either the data owner would send you directly the private model, or they would even serve that model to make predictions on your behalf. So then there's really no chance of well, there's, let's say, reduced chance of, and this entire flow would be organized by Ocean protocols. So it's all organized with the Ethereum smart contracts using a set of service execution agreement conditions. So that's just sort of the overall picture. And this is something that we're actively developing currently. So current status is that we have this marketplace which can register assets, and this is our next milestone, is bringing the model to the data. So again, just as a summary, so you would receive some type of generator for your data. So it could be even some sample data. You would build your pipeline, package it, send it to the data owner. You would then, of course, receive some type of information whether or not your model has succeeded or not. So maybe there's just a straight up error in the script, and then you would get that back as a log file. Or you would actually get the logs over time as the model is training. And this could also be seen as some type of proving that this model is successfully trained. So then you would even get some indication of the value of the data without seeing the data. You could furthermore have independent verifiers check the honesty of the data owner, and in the end you would get your trained model or use that to directly in production, and finally get some business value out of this data, which you were not able to see before. So I just wanted to highlight that point of no data escape. So now let's talk a little bit about the architecture of Ocean protocols. So at a very high level, we have the user, so some type of client, and this could be this Commons marketplace as a browser application. And I'll show you another demonstration for a data science user after these few slides. So the user is always going to interact with Ocean typically through some client library. And in this case, we have three different languages supported for libraries, and that's Python, JavaScript, and Java. So these client libraries are typically making heavy use of the Web3 library. If you're familiar with the blockchain space, this is an Ethereum API for interacting with blockchain smart contracts and blockchain networks. So with this client library, we then are able to interact with the core components of Ocean Protocol. So the first core component I'll highlight is the metadata storage. And this is literally storing the DDO or the DID document, which is again just the metadata for any asset. And this is a JSON file, or it's, in our case, we support MongoDB, Elasticsearch, and this is simply a REST API that you can call from the client library. Another important aspect is negotiating the access to assets. So there's two components that play a key role. One is the secret store, which is a project from the Parity organization, which is well known in the Ethereum ecosystem, which will guarantee, well, it's cryptographically showing that you can maintain a secret such as the URL of your assets is always encrypted and hidden behind the secret store. So nobody can access it unless you provide the access to that yourself. So again, that's getting back to the concept of you as a data owner, you can cryptographically guarantee that you actually maintain ownership of that asset. So this component is called Brizo, and it's another REST API component, so Web 2.0 microservice, which negotiates the access control. And so it's listening to events from the blockchain and guaranteeing that you as a user, for example, have sufficient funds to buy the asset before you buy it, or before you're given access to it, for example. So the other most important and underlying component is, of course, the entire blockchain network itself. So again, we have several different networks. We have, for testing, we have a local testnet, which can be instantiated and run from Docker very easily with a single script. We also have some testnets which are running in the cloud, so they're running on AWS and is public. So we'll be connecting to Nile in a demonstration in a few slides. And then finally, we also have this public production network, which is exactly what this front end is connecting to. So again, this is how I'm connecting to the blockchain network. I'm connecting to this public production network. So that's just a really high level overview of the different types of components that we have. And we can discuss a few more details later, but for now, I'm just going to move on in the interest of time and talk a little bit about the data science aspect. So as a data scientist, I'm typically programming in Python. I'm typically having many different libraries, and many data scientists are also not necessarily comfortable with configuring their environments or their data access. They might have some machine learning engineers to support them. And that's why this project called Jupyter Lab has gained in popularity in recent years. So Jupyter Lab is simply a front end, and you can treat it as an IDE. So typically when I'm programming a large project, I will use a more traditional IDE like PyCharm or some other type of, some other IDE. But if it's a smaller project, or if it's important for me to communicate this algorithm, Jupyter Lab is a very nice way to do that. So you can include things like pictures and documentation and formatting, and you can also, using the Jupyter Hub project, you can allow other people to access pre-configured environments using Docker. So that would be, let's say, a separation of scope. You would have your machine learning engineers, your data engineers preparing these environments for the data scientists. So you listeners can also try this yourselves by going to datascience.oceanprotocol.com. This is our second sort of front-end facing, customer-facing demonstration sandbox. And by going here, you can actually spin up a Jupyter Lab instance, which is then connected to our testnet. So when you log in, after you log in, you're going to be greeted with a screen such as this. So on the left side, we have a series of notebooks, and these are Python notebooks and some other files. So when you click on one of these notebooks, it's going to open in the left pane. And the point of this project called Manta Ray is to serve as a series of tutorials and demonstrations for new users, but also allow you to test different ideas. So the nice thing is that this is actually connected to our test network without any configuration required from your side at all. So we would then typically iterate through the cells. So that's the other nice thing about this type of environment, is that this is running fully in the browser, but I can also start to edit some cells. So let's try that. So I'm going to start getting a configuration object. And you might want to ask, for example, yeah, what is this configuration object and what type of attributes does it have? Well, you can actually start inspecting that. So I type in configuration and enter, and then I would see, okay, it's a Python object, and I can try to print it. So you can see it's a very convenient way to start inspecting different types of, it's an interactive loop that I can use to start inspecting the various objects and start testing my own ideas. So the next thing I'll do is instantiate the ocean object itself, and then we can gain some insight. So for example, here I'm connecting to the Nile, which is our test network, and I can see that I have 62 accounts, which I can use to test some different workflows. So that's just this script here is just called check our library, check squid. That's the name of our API. This is another one that we can use to check our endpoints. So such of our components, as I listed before. So Aquarius is the name of our metadata storage. Brizo is the name of the access control microservice. And then we also have the main blockchain node and our secret store. So you can see it's saying, yes, I'm successfully connected. And it's also going to show you the URLs. So with that as a basis, then we can start actually interacting with the protocol. So here, in any case, I need to import and instantiate the Ocean Protocol class, which is the main access point for interacting with Ocean. And in this case, in this notebook, I'm going to talk about using accounts. So in this case, we're going to select one test account at random. So this is the blockchain account address. We're going to list them all. So an account has a certain amount of Ocean token and a certain amount of Ethereum. So the Ocean token is the actual currency or token that you would use to purchase, so buy and sell assets on Ocean Protocol. And we also have a balance of Ethereum. And we can do things like in our test network, we can start thinking about, yeah, I would like to actually get some more Ocean token to test with. And you can see that in this case, I'm calling the API, so Ocean class, and I'm calling the accounts object and the request tokens method. And I'm passing in my account, the selected account, and the number of tokens that I'd like to receive. And then we can see that it did successfully update from 17 to 18. So that's basically our first sort of basic interaction. And then we can finally get to more complex use cases such as publishing an asset. And so to publish an asset, we can then start to access the other methods of Ocean Protocol, such as the .create method. So I won't go into more detail on this, but this is then for you to check out and try yourselves. So let's go back to the presentation. And I will just sort of wrap up after I described one last point, and that is going to be, how can you, as a developer, how can you start to investigate Ocean Protocol, to learn more about it? How can you build on Ocean Protocol? So the first thing I'll point out is that Ocean Protocol, and I'll just reiterate, is a nonprofit foundation with a mandate for open source software. So in this GitHub organization, so github.com/Ocean Protocol, you'll find every single repository that we have. So we have, for example, this Aquarius repository. Let's see if I can find it. I'll just search for it. So if you're curious about, let's say, how this repository works, or even if you encounter some bug, then we would encourage you to create a GitHub issue after chat. You can also chat with us on the Gitter channel. So where's my Gitter channel? I'll show it at the end. So in this case, we see Aquarius, and yeah, it's all open source. So we can see it's a Python application, and in this case, we're going to be running it with Flask, and then deploying that to the internet. So go back to the organization. So that's for you to explore. We also have extensive documentation for the core concepts and the core components. So in order to get to the documentation, you would again just start at oceanprotocol.com, and then at developers, you would be landing on this page. So here we have again a link to our GitHub channel and also to Gitter. So if you have any technical issues, please log into Gitter and just let us know if there's an issue. And then we can point you at least to the right GitHub repo, and we can also notify our dev team to start working on some issues. So in addition to that, we have an extensive documentation page. So we have core concepts, some setup guides, and some tutorials. Our REST APIs are all documented with Swagger and also represented here. We also have a quick start. So really to get started with Ocean on a local environment, this is, and that's going to start, that would start actually pulling Docker containers, spinning them up, and you would then basically be running complete Ocean Protocol stack on your local machine for testing. I think that's about everything I wanted to show here. We can maybe look at some more details. So in the quick start, we have some ideas like setting up a marketplace, acting as a publisher, and in the tutorials, we also have some information. So for example, because a lot of people are new to blockchain and decentralized applications, this could be an interesting starting point just to understand what this plugin is doing, MetaMask. Of course, for the blockchain purists out there, you can also, of course, sign transactions with a local node if you don't feel comfortable using MetaMask. And yeah, so we have a great set of tutorials for setting up all the components, your wallets, etc. Okay, so I think that's about everything for the developer tools. Great, so I'll just wrap up a little bit. So again, we can see a different view of this type of artificial intelligence ecosystem, and it's requiring these types of assets. And assets for us are more than just data. So data is, of course, a key foundation for artificial intelligence. But we also consider these types of scripts, compute itself, models, and the actual production value of artificial intelligence. These are all types of assets that can be registered on Ocean Protocol, and they can be traded, so bought and sold. They can be verified. So in order to ensure that the quality of these assets is high, we also enable things like curation, so that any type of assets can get, let's say, and this is up to you as a marketplace owner, you can decide if you would like to allow upvotes, downvotes, or 5 stars type of model to allow people to vote on your assets, or maybe there's some even automated way to guarantee the quality of the assets. So we also have then, this is actually becoming some type of inter-service network. So data can also be considered a service if it's associated with the serving of the data. So the download of a data is this type of service, or access to data is a service. And of course, the core reason why blockchain technology is so valuable, it's not just a distributed database, but it actually allows incentive to be added on chain. So incentivizing people is really a key superpower of a blockchain, and that's just an economic concept in the decentralized ecosystem, that using such a concept such as Ocean Token, we can actually incentivize people to act correctly and to not become bad actors in the network. And overall, we don't really know what this new AI ecosystem will look like, but we hope that we can spawn some interesting ideas and allow people to discover what this ecosystem looks like. So again, Ocean Protocol as a nonprofit foundation is interested in building this underlying protocol or public utility to allow other people, so the real experts for data science and these data owners and the problem solvers, for them to discover more ways to use the data and to unlock the real potential of AI. So there's a lot of ways to get involved on Twitter, Medium. There's some really great Medium articles as well that I can really recommend. GitHub, and of course, starting out with our website at oceanprotocol.com, you can then get involved and help us to build this new data economy. Okay, so that's everything for the presentation. I'll now open up the floor to questions. So Mohammed, do you want to jump in, or should I just start reading the questions?
Yes, go ahead, Marcus. Thanks for this presentation. Go ahead with the questions, please.
All right, so I'm just going to scroll up. So, okay. So I see one question, is this available to implement in the Middle East? Yes, of course. So Ethereum, to run an Ethereum blockchain node or to access the Ethereum blockchain requires only the internet. And as long as you have access to that, then you can use Ocean Protocol directly. So again, you can of course test this directly by just starting to play with it on our Commons Marketplace or this data science workbook. Yeah. So let's take another question. Training program. Okay. Okay. So can this work with the new Facebook Libra coin? I don't know what the new Libra coin is. I haven't read the white paper. Yeah, I'm not sure. We'll see what it says. So Ocean Protocol, I will mention that Ocean Protocol is a therefore the real value of Ocean Protocol and the Ocean token itself lies in using the network itself for doing things like not only providing data, but also, let's say, validating data. So that's maybe one core difference between the Ocean token and the Libra coin. So the Libra coin is as far as we know at this point in time, is a stable coin and acting as more of a currency. So in that respect, there's not a lot of overlap, let's say, between the two. Next question. So one question is, do we have to pay fees to use that system? So one thing that's important to note, if you're executing smart contracts on the Ethereum mainnet, you're actually executing code on thousands of different nodes or different computers. And this is part of the Ethereum blockchain node network. And in order for this service to be provided, this execution of the smart contracts and the security of the smart contracts, these blockchain nodes require some incentive, and they're getting this in the form of what's called gas, and that is simply Ethereum. And they're getting, therefore, some value in order to use Ethereum. So in that sense, to execute smart contracts in the Ethereum mainnet, you do have to pay fees in the form of gas. However, for Ocean Protocol, we are running on a different consensus mechanism called proof of authority. And in this case, the fees are actually not paid in any type of value, because the gas fee is essentially free in that network. So there's no fees at all. Just to make it clear, there's no fees to use Ocean Protocol. The only aspect you would transfer value in is simply the buying and selling of assets. And that's 100% going to the data provider or the provider of the model. Okay, I hope that answers that question. So can we publish a non-free data set on the Commons Marketplace. This will not work. We block any price. So I can actually, just as a demonstration, we can go to the definition of what's, let's go to the Ocean Protocol OEP. So on our public GitHub repos, we have Ocean enhancement proposals, and these are coming from the public, or anyone can provide concepts and ideas for us to implement in the core protocol. So for example, we can now look at the metadata of an asset, and we can see exactly what is inside this type of, so this is a view of the actual metadata, and we have one attribute called price, and you can change this price, but currently on the marketplace, the Commons Marketplace, it wouldn't make sense to publish anything with any value other than 0. So as far as I know, it would just not even let you publish it. And so the idea of the Commons Marketplace is that it would actually allow you to fork it and build a marketplace, a new marketplace for priced assets. And that's what we're hoping to. So let's see. I think that pretty much covers the main questions. So someone's asking what are support vectors, but this is more of a data science topic. I would just recommend that you look at just some Google searching for that. That's sort of outside the scope of Ocean Protocol. And someone else is asking about more webinars. Yes, we can discuss this and do some more educational training. I would again start just by saying go to our demonstrations. We also have some videos on YouTube. Let me see if I can find. Let's see, Ocean Protocol. So we have some overall videos, but we also have a series of tutorials. So it also highlight that. For example, this is me giving some tutorials on this exactly this topic of these Jupyter notebooks. So that would be a great place to start as well. And the internet connection is a bit slow, so it's not loading. But if you search Ocean Protocol on YouTube, or just again go to oceanprotocol.com, you can find out some more information. And I think I'll close the webinar now since I don't see any new questions coming up. So thank you very much for listening. And there are many different ways to get in touch with us on Gitter, on our Twitter page, Slack. What else do we have? What's this other? We have so many channels. It's tough to keep track of everything.
Okay.
So, yeah.
Yes, I would like at the end of this webinar to thank Marcus and everybody attended today from the technology community. We have received a lot, so thank you message for Marcus, and really we thank him fully for lots of efforts he made during today and the past couple of days. We appreciate his efforts much from Egypt.
Thank you guys.
Okay.
Have a great day and keep in touch.
Okay, thank you, Marcus. See you again.